Right, we are going to be looking at some possible outcomes and probability of certain events occurring. Alright, here we've got Carla has 4 hats and 4 scarves for winter weather. She picks one of each to wear. How many hat and scarf combinations are there? Well, I'm going to start by branching off into the hats. So there's 4 hats, so I'm going to have 4 branches coming off here. I'll call this H1 for hat 1, H2 for hat 2, H3 for hat 3, and H4 for the 4th hat. And then from there we can choose 4 scarves. So I'm going to branch off on each of these 4 times. And then for each one of those we've got scarf 1, scarf 2, scarf 3, and scarf 4. So there's 4 scarves that could go with each hat. So then what you can do is just look at the bottom layer of the tree diagram. So here, how many possible things are there? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 total outcomes, combinations. A shortcut, the counting principle, would be since you've got 4 hats and 4 scarves, so the counting principle would just be to multiply those together. So you got 4 times 4, which equals 16. Alright, so for this one we have Miss Wong is redecorating her office. She has a choice of 3 colors of paint, 4 kinds of curtains, and 4 kinds of carpet. How many different ways are there to redecorate? So I'm going to start with the first branch. We've got 3 colors of paint. And I'm going to let this be paint 1, paint 2, paint 3. From there we can do 4 kinds of curtains. And I'm going to let the curtains be CU, so there's CU1, CU2, CU3, and I'm going to do this for each of them. Okay, so that's all the curtains. And then there's 4 kinds of carpet coming off of them. So we've got from here 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So I'm going to do this for each of them. And look at how many, count all those up. Or if we did the counting principle, we could just multiply everything together. We've got 3 kinds of paint times 4 kinds of curtains times 4 kinds of carpet, which gives us 48 ways. Alright, here we have a situation where a coin is flipped 20 times and the results are recorded in the frequency table there in green. The theoretical probability of getting heads. Well, in theory, just without doing anything, if we had a coin and we flipped it, what's the chance of getting heads? Well, we can either get heads or tails. So there's 2 possible outcomes. The chance of getting heads is only 1. So we got 1 out of 2 chance on that. Theoretical probability of getting tails. Well, again, you can only have 2 possible outcomes, and the chance of getting tails is 1. Now, the experimental, you look at the data that was recorded, and we see that there were 20 outcomes. Of those outcomes, how many of them were heads? Well, there's 13. So 13 out of 20 is the experimental probability of getting a head. And then for the tails, there were 20 possible outcomes, and of those total outcomes, 7 times was there a tail. Alright, you and your friends designed t-shirts with emblems. You were selling them to raise money. The table shows the number of t-shirts you have in each design, and students choose their t-shirt at random. What's the probability that you're going to get a red t-shirt chosen? Well, first of all, let's find out the total number of shirts. And if you find a total number of shirts, we've got 10 plus 6 plus 8 plus 6, which equals 30. We have 30 total shirts. And how about the total number of red? Well, red we have 6 plus 6, which is 12. So we have 30 shirts. Of them, 12 are red. And we can reduce this. Those are both even numbers, so we can reduce this down to 6/15. Those are both divisible by 3, so this can be 2/5. Alright, then we're looking at this next part. What's the probability of a shirt being chosen with a silver emblem? Well, we do know there are 30 shirts total. We did that in the previous part of the problem. Well, we got to find out the silver emblem. So if we look at the table, we see that there are 8 and 6 of them, so that gives us 14. So 14 of the 30 have a silver emblem. That can be reduced. Those are both even numbers, so we can cut that both in half, and we have a 7/15 chance.